Hello and welcome. Today, we're going to do something pretty cool. We're going to completely remap how you think about numbers. Seriously. Forget seeing them as just points on a single, flat line. We're about to see them for what they really are, locations on a rich, two-dimensional map. So, let's unfold the chart and get started. And this right here, this is the big idea. You've probably spent your whole life picturing numbers on a line that just stretches out forever, left and right. But what if I told you that line is just one single street in an entire city? Yeah, let's go explore the whole grid together. You see, the really crucial jump here is from one dimension to two. That number line you know and love, it can only hold real numbers. But this number plane, it adds a whole new axis, a whole new direction. And that opens up a universe where we can finally map complex numbers. So what do we even call this new map? Well, it has a name, and it's our absolute key to navigating this new world. This is it, the Argand Diagram. And honestly, just think of it like a geographical map. The horizontal axis, the one you're already used to, that's the real axis. Let's call it our east-west street. And that new vertical axis, that's the imaginary axis, our north-south avenue. Every single complex number has a unique address right here on this grid.
And plotting a number is as simple as finding an address on that map. For any number, let's say a plus bi, you just move a units horizontally and then b units vertically. That's it. You found your spot. Seriously, if you can find coordinates on a map, you can totally master the Argand diagram.
Okay, so we've placed our pin on the map. A really natural question comes next, right? What's the straight line distance to get there from where we started? Right at the center, the origin, point 0. How do we measure that journey? Well, the answer to that very question has a specific name. It's the tool that tells us the size or the magnitude of our complex number. Let's find out what it is. It's called the modulus, which I know sounds kind of fancy, but it's just a word for the distance from the center. And you know what's cool? To find this distance, we get to use a tool you probably already know and love, the good old Pythagorean theorem. And here's the tool itself. The modulus of some number z is just the square root of the real part squared plus the imaginary part squared. That's it. This is our trusty distance calculator for every single point on this map. All right, enough theory. Let's take this map for a test drive, shall we? We're going to go on a little expedition to find the number 1 minus I. We'll plot its location, and then we'll calculate its exact distance from home. Okay, first things first, let's break down our number. Z equals 1 minus I. The real part, our a, is 1. That just means we move 1 unit to the right. The imaginary part, b, is negative 1. So that means we move 1 unit down. Our coordinates are 1, negative 1. Easy enough, right? Now we just plug those values into our formula. The modulus is the square root of 1 squared plus negative 1 squared. Now just remember, when you square that negative 1, it becomes positive 1. So our calculation gets super simple. It's just the square root of 1 plus 1. And there's our answer. The exact distance, the modulus of 1 minus I, is the square root of 2. That is exactly how far our number lives from the very center of the universe of numbers. Pretty cool. But hang on. Distance is only half the story on a map, isn't it? You also need a direction. In the complex plane, that direction is an angle we call the argument. Just knowing the distance doesn't tell you where you are, it only tells you how far. For the full picture, you need both. So let's bring it all home. We started by kind of challenging this old idea of a simple number line, and we've ended up with this far richer, and I think, much more intuitive way to actually see numbers. Look, here's what I really want you to take away from all of this. Complex numbers, they're locations. The Argand diagram is your map, and the modulus, that's just the distance from the start to that location. Once you see it this way, all of a sudden the complex part doesn't seem so complex anymore, does it? So we've mastered distance. That's the modulus. And we just got a little hint that every location also has a direction, the argument. So here's the final thought I want to leave you with. How does combining distance and direction change everything? How does that open up brand new ways to multiply, divide, and really truly understand these numbers? Well, that's the key to something called polar form. But we'll save that for our next expedition.